Hey, welcome Woodstock biology students to what I hope is a short but informative video about the ideas of monomers and polymers, and as it says here, an introduction to chains of carbohydrates, okay? So we're going to talk a little bit about the way that nutrition out there in the world gets taken in by us and by really any organism and then gets broken down into smaller pieces. And we're going to be introducing words like monomers and polymers and so forth. Okay, so let's get underway. Here's a quick little cartoon version of monomers and polymers. Okay, monomers you see here, we're going to model those or imagine those as these five circles, these individual molecules of different types. We're going to see that there are monomers in the carbohydrate world. There are monomers in the world of proteins and so forth. But right now we're just talking sort of generally about monomers. And these are individual molecules, okay? And if they get strung together, as you see down here, like if we connect those five to one another, we will create a polymer, a chain of monomers. So the MER, when you look up on your list of biology words, that's going to be a suffix that means an item or a single thing. And mono means one. So this is like a single item and five single items. And poly, of course, means many. And so this is a single molecule with many items in it, many individual pieces in it, okay? Now, I'm just going to move myself out of here for a second, okay? Cells need the monomer version of the molecule, so the single molecule like glucose, okay? Cells can't handle long chains of glucose. But nature often packages monomers in really large chains. So, for example, in apples and potatoes and so forth, there are just really, really, really long chains of glucose molecules and related sugars, okay? We'll take a look at that in just a bit. So, in the world of carbohydrates, we've already been thinking about a molecule called glucose, C6H12O6, and we know that that's a hexagon base with lots of other oxygens and hydrogens coming off of the corners here, okay? But there are variations on that, variations on C6H12O6 that are called isomers. These are molecules that have the exact same chemical formula, and so have a lot of the same properties, but are just sort of rearranged differently. And so if you go from a hexagonal base to a pentagonal base, you can change the molecule name from glucose to fructose, even though it's got the exact same number of elements, just slightly rearranged, okay? And then there's a third version of C6H12O6 that's called galactose, okay? So this is back to a hexagon and just a slight rearrangement of the hydrogens and oxygens coming off of the corners of the hexagon, okay? These three isomers, iso means the same, so that means literally this means the same item, okay, in some way, right? They have the same chemical formula but a different structure, and these are the three monomers in the world of carbohydrates. So carbs have three monomers: glucose, fructose, and galactose. And there's a category of those three. Those three together are called the monosaccharides. Saccharide meaning sweetener or sweetness or something like that. So a single sweet molecule, if you will. Okay, glucose, fructose, and galactose. Now, these can be strung together, but I want to show you a preliminary these can be strung together to make polymers, okay? But I want to show you an intermediate step that gets taken with each of these monomers. Right-hand side of the page, you see disaccharides. Okay, so di meaning double or two. So if glucose is connected to another glucose molecules, these two blue ones here, right? If two glucoses are connected together, they create a disaccharide called maltose, all right? And if you connect glucose to fructose, you get something called sucrose, and this is typically what you see, what we have in table sugar is sucrose, all right? So what we've been working with in class has been sucrose, all right? And then finally, the third combination, and you notice that all three of these combinations contain glucose. It's glucose with galactose, and that combination is something which gives us lactose, and we've referred to this in class a few times as, a molecule that needs to be broken down by lactase. And if you or someone you know has trouble processing dairy products have a lot of lactose in it. It means that that person might not have enough lactase, and they may not be able to break down this molecule to digest properly. Okay. All right, in the next video, I'm going to show you how these will come together, how these bonds will be made, and how everything gets strung together into long chains of polymers. Okay, thanks very much.